Production code needs to handle several distinct failure modes, each with a different correct response. Rate limit errors for 129s should retry with exponential backoff and jitter, not immediately in a tight loop, which worsens the situation for everyone sharing the same rate limit pool. Overloaded or server errors, 5xx, are generally safe to retry with backoff, typically transient. Invalid request errors, other 4xx codes, indicate a bug in your own request and won't be fixed by retrying, log, and alert instead. And timeouts need sensible client-side limits and a deliberate decision about whether a timed-out request is safe to retry, since it may or may not have already been processed. Official SDKs typically implement sensible default retry behavior. Know what your SDK does by default before adding your own layer on top. In production, streaming raises additional concerns beyond the basic mechanics. Client disconnects midstream. Decide whether to cancel the underlying request to save cost, or let it complete server-side for logging or caching. Partial output handling. If a stream is interrupted, define a behavior, show what was received with an error indicator, or discard and show an error, rather than leaving the UI silently stuck. And streaming and structured output don't mix cleanly. If you're relying on tool use or a strict output format, decide whether to stream at all for that request type, since a partially streamed JSON blob isn't valid to act on until complete. Model choice is your biggest latency lever. Haiku-tier models respond meaningfully faster than top-tier models for a given task, and if a use case tolerates it, this usually beats micro-optimizing request plumbing. Reduce round trips in the tool use loop where possible, batch data fetching into fewer, richer tool calls rather than many narrow ones. Prompt caching improves time to first token, not just cost, for repeated large context. And set user expectations with UI, not just backend speed. A streaming response that starts appearing in under a second feels fast, even if total generation takes several seconds, while a blocking spinner for the same duration feels slow. Claude has built-in safety behaviors that can result in a refusal or a modified response for certain requests, independent of your own application logic. Handle refusals gracefully in your UI. Don't assume every response is the content you asked for. A refusal usually reads distinctly differently from a normal completion, so detect it and use a sensible fallback message rather than displaying it as the intended output. Design prompts and features to avoid triggering unnecessary refusals. For legitimate sensitive adjacent domains like security tooling or medical information, clear framing about the legitimate purpose reduces false positive refusals. And don't try to engineer around safety behavior for genuinely disallowed use cases. If a feature only works by defeating guardrails, reconsider the feature, not the prompt. Beyond quality monitoring, production observability for a Claude-powered feature typically tracks latency percentiles, P50, P95, P99, per model and endpoint, since tail latency is what users actually notice. Token usage and cost broken down by feature, customer, or model tier, essential for cost control and routing decisions. Error and retry rates by error type, to distinguish a too low rate limit tier from a request construction bug from the API having a bad day. And stop reason distribution as a cheap, continuous signal of response health. For workloads that don't need an immediate response, bulk classification of a backlog, nightly report generation, large-scale data enrichment, a batches API, processing many requests asynchronously, typically at lower cost than synchronous calls, is usually a better fit than firing thousands of synchronous requests through your normal rate limit tier. Recognize the pattern. If a workload's defining trait is high volume but not latency sensitive, reach for batch processing rather than parallelizing synchronous calls against your interactive rate limit. Take the triage assistance error handling and explicitly write out, in comments or a short design note, what your code does for each of a 429, a 500, a 400 with a bad schema, and a client-side timeout. If any of the four just falls through to a generic catch-all, that's a gap worth fixing before calling the feature production ready. To recap, different error types need different handling. Back off and retry for 429 and 5xx. Fix and don't retry for request construction 4xx errors, and a deliberate policy for timeouts. Streaming needs defined behavior for disconnects and partial output, and doesn't mix well with strict structured output. Model tier choice is the biggest latency lever. Caching improves time to first token, and UI perception of speed matters as much as raw latency. Detect and gracefully handle safety-driven refusals rather than displaying them as intended output. And track latency percentiles, cost breakdowns, and error rates using a batches API for high-volume, non-latency sensitive workloads.